Bro, how crazy would it be if there was a game that just started with like a big thunder sound, like BROW?
Oh, bro, you mean something like this? Hey, everybody. What you're looking at is a short simulative experience called Strange Shops. I'd like to preface by saying this project was created as the final submission for Unity's junior programmer learning pathway that they offer. And the core driving principle of the project was to use the four pillars of programming, namely abstraction, inheritance, polymorphism, and encapsulation. And you'll see how I let those sort of drive the structure of the project, at least in the beginning. So without further ado, let's jump right in. All right, so what's happening in this project? Well, the core of what's going on is a player character finds themselves in this brick cafeteria. It's a little spooky. There's not really certainty as to what's going on. The player selects from one of three available restaurants to which they're greeted by the chef that manages that restaurant. They are able to order one food item off of the chef's menu, and then the chef goes back to the kitchen to prepare it and bring the food item back out to the player, which they then get to delectably enjoy. Let's go ahead and pull up the project so we can take a look at how things are working under the hood. All right, everybody, welcome to the Unity project. Now, there's a lot to digest here. I'm not going to lie, but in an effort to not take up too much of your time, I'm just going to go ahead and talk about a couple of the concepts here. Uh, so I think the most reasonable place to start is the heartbeat of the project, what everything is structured around, which is the chefs. Just to show you, there's Carla chilling behind her doorway, ready to serve you. So let's pop over into Visual Studio. I've got a couple of scripts here set up to walk through. And real quick, I'm going to flash on the screen here. If you can make out my chicken scratch, some notes from my brainstorming. And the first idea I actually had for this project is the one I went with. And I was planning to have a base chef class and a couple of sub chef classes that would inherit from it. And that's exactly what happened. So what we're looking at here is the base chef class, which is an abstract class that has a couple of virtual methods which are overridden in each sub-chef class. There's some protected coroutines, things like that, that each chef is meant to access the exact same way. But some of the things that differ are the actual data that the components, the managers of the game display, which I'll show you is linked to the chef data scriptable object system that I set in place. And then real quick, just want to make a note of the little notes that I left for myself. I was really using the pillars of programming as my guiding principles when I started working on this project. So I made sure to drop little notes for myself. But anyways, let's go ahead and pop into one of the sub-chef classes. Carla is the most simple, which isn't saying much. It's not too far off from the others. And pretty much what differs between the chefs is the time that they move to the center stage, so how fast they move, and then what animations they procure. So that's basically all the sub-chef class is doing. It's initializing the components and then telling the chef to move according to different game events that are triggered. I'll show you that here in a minute. And then animating the chef according to different animation values. So just to show you Sandy, exact same thing, but she moves a little faster. And she's got a different animation sequence set up, which is this smoking coroutine. So let's go back into Unity and let's talk about the data a little bit that I just alluded to. So the way that the different components of the game, the managers and the UI elements themselves know what to display to the player is based on the actual chef data itself. So that's these scriptable objects here, which just act as data containers. And they've got all the great information that each chef has set up, which I set up for them. So there's different dialogue options that the UI displays according to which chef is active. There's the food that's actually available. So these available food names are linked to the UI food menu, which I'll show you here real fast. Right here, it's all blank, but it gets populated by the values according to which chef is active. Let me pop back into the scriptable object. The actual prefabs of the food that that chef has available is stored here as well. And then ultimately, the way everything is linked together is by the designated doorway. So which doorway is clicked tells all the different components what basically what's going on in the game at any given time. And then I want to briefly gloss over the game event system too that I had made mention of. And this is the exact same game event system that I mentioned in my last video, if you want to go check it out. But it's the one from Ray Wenderlich, which is essentially just a system of setting up events as components. So to give you a quick example, I will let's go and pop into one of the chefs together, and we'll take a look at how it's working. So this is just one small example, but here on one of the chefs, we've got all of these game event listeners. And if we go ahead and open one of them up, you'll see that it's set up to listen to a game event and procure a response, which is a Unity event here, when that game event is raised. So in this case, when the door is clicked, Fred, the sub-chef class of Fred, activates his chef sequence. And again, this is just one small example, but I've got these kind of all over the game, which you'll see if I pop open in the project window, the game events, you'll see that I utilize these extensively kind of throughout the sequence of the player interacting with the program. Different events are being triggered that are keeping the game moving along. I think now is as good a time as any to get into some of the problems I ran into on this project. There were two big problems that really stopped me in my tracks here, and I wouldn't call them problems as much as I would challenges. We eventually got around them, and I'll talk to you about how we did so. So the first one was lighting. I'm going to go ahead and pop open the lighting tab here just to kind of have it accompany the conversation. But lighting, I had no idea, no preconceived notions of how difficult it could be to get a light map baked to allow the baked lighting in the game to simplify performance. So let me take a couple steps back. I was working on the indoor portion of the game that we just saw, right? I created the whole outside portion of the game, which has its own lighting. And then I thought, hey, let me go ahead and implement a second scene that's going to hold the start menu. Player clicks start, and then it loads over into the main scene. Awesome. Simple, right? Well, it didn't end up being as simple as I thought. So it turns out that Unity automatically bakes the light maps for the scene that is loaded in at runtime, and any other scenes that are progressively loaded after are not going to be baked in and need to have a baked light map generated. So I started playing around with baking the light map, and it turns out it can be a pretty intensive process. All of these settings here dictate sort of the quality of the light map and how fast the process will occur. I was playing around with all of the settings. I tried to get the samples as low as possible. I try to get everything as low as possible, and it was just taking an incredible amount of time. And it turns out, these things can take upwards of 24 hours and still fail. So I realized it really just wasn't worth it for the simple uh, use case that I was trying to achieve here. So all I did was create a UI overlay, which is the first thing the player sees, and then when they click through the couple of screens and eventually click start, the render manager takes over and makes the makes the menu UI disappear and basically starts the game. So super simple workaround. The second challenge that I ran into is it was UI related. Well, I should say it was raycast related. Let me go ahead and open up the end game canvas. So I ran into this when I started working on the end game portion, and I set up a just clicking on a few things to get it set up for you here so you can see what I'm talking about. But I had set up this endgame UI, which is transparent by default because it lerps in, but that's just this little UI element that you see here on the screen. So basically, when the player goes through one full sequence with a chef, this little door pops up and they're able to click this little doorway. The canvas lerps in and they get the option to start the exit sequence of the game, which I won't spoil too much. But what I had run into while building this out was the issue of the doors actually still being interactable. So the way that the doors are set up is with the event triggers, pointer enter, pointer exit, I think is what they're called. And I dove into the forums. I started doing some research, and it turns out that this has been a sore spot, it seems like, for the Unity community for quite some time. People were saying it's a broken system, that the raycasts go through even when you've got the raycasts blocked in the canvas group. So the simple workaround for me was just to create some Boolean checks in the game manager that basically don't allow anything to be interacted with when this endgame interface pops up. So anyways, I've surely babbled for long enough. If you're still watching, I appreciate you sticking around. There's plenty more I could get into here with this project, but we'll save it for another day. And I will leave the end game up to you to figure out what is in store for our player. Anyways, thank you for watching. Until next time, peace.